Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before, or even considered taking up programming. Today we will look at user-defined type variables, what they are, and what benefits can they bring to PowerBasic programming. So what are user-defined type variables, and how can I use them? In previous videos, we looked at both string and numeric variables, and followed that up with a video on string and numeric arrays. Today we are going to go one stage further and combine all of these in an array of user-defined type variables. PowerBasic, like many other programming languages, stores data in containers called variables. This data is stored in a format that makes it more easy to manipulate. For example, numeric data is likely to be summed, counted, or have some other mathematical operation performed upon it. And as such, it's stored in a format where that can be done more easily. String variables contain text and are stored in a format that allows the text to be chopped up, appended to other strings, and sections of text removed or replaced. User-defined types are a hybrid of these two basic types that allows you, the programmer, to create a data container that fits your needs. So how can I use them? Say for example, you are given the task of keeping track of some data on students. First name and surname, their age, and the amount of currency they have on their student card. How could we store this information in a user-defined type? Let's have a look at some code to see how this could be done. Here we are in the PowerBasic console compiler. User-defined types can be used both within the console compiler and the PowerBasic Windows compiler. So since we're going to be tracking some student data, we need to create our user-defined type. And we need to give our type a name. So we'll call this one UDT student data. You can name your user-defined types anything you wish, but I find it quite useful to put a prefix at the beginning of the name to indicate that it is in fact a user-defined type. Now we have to define the elements of our user-defined type. As we said earlier, we're going to keep track of the forename, the surname, the age, and a currency balance. So we'll need to create one line of code for each of these elements. So I have named one of the elements forename and defined that as a string. Now for user-defined types, strings need to be of a fixed length, unlike the dynamic strings we've seen in previous videos. So it's important to create the string large enough to contain all the information you're going to be storing within it. So in this case, I'm creating a fixed length string of 100 characters. We'll do exactly the same for the surname. As we're going to be keeping track of the age of the student, we can define that as a long variable. So we now have three elements, the forename, the surname, and the age within our user-defined type. The final element we want to keep track of is a currency balance. We can use a special numeric variable type called currency. The currency variable type allows you to keep track of numbers, and in this case it will keep numbers to 4 decimal places after the decimal point. Now most currencies only have 2 values after the decimal point. So we can use an extended version of the currency type which will ensure that it keeps track only of 2 values after the decimal point. So now that we've defined our student data user-defined type, how do we actually use it to store information? In the main section of our code, we want to dimension an array to keep track of our students' data. We can use the dim command to instruct PowerBasic that we're about to dimension an array. And then after the name of the array, we need to tell PowerBasic how many elements we want to keep track of. So say for example we want to keep track of 10 students. Then within the brackets we can put 1 to 10. This will dimension the array as 10 elements, 10 rows of data. Additionally, we'll need to tell Power Basic what type of variable this array is going to be of. In our previous videos, we showed you how to dimension string arrays and numeric arrays. This is going to be a user-defined type array. All we need to do here is put as and then the name of the user-defined type we defined earlier. UDT student data. So we have now defined an array of 10 rows of data, and each row is going to contain the information in that user-defined type. So how would we actually reference it in the code? If we wish to populate the forename of the first student, we would put in the name of the array and in brackets the row in the array we want to update, and then a dot, a period, and then the element of the user-defined type we are populating, in this case the forename. Then an equals, and then in double quotes the string that's going to populate into that. So for the surname we will do exactly the same thing, and the element we're referencing is .surname. We will then continue to populate the rest of the user-defined type by populating the age and then the balance. So using this method you can populate each of the elements of a row in this user-defined type array. To make your code look a little neater and to save a bit of typing, we're going to now use the prefix command. This prefix command you see on screen now is exactly the same as the previous 4 lines of code. It just involves less typing. When Power Basic does its compilation, it will prefix each of the following 4 lines with the A, use student data, open bracket 1, close bracket dot. So it will look exactly like this line of code. It will then do the same for the surname, the age and the balance. This certainly makes your code look much neater and does involve a lot less typing. So if we wish to populate the second row in the array for a second student, we can do exactly the same thing. The only difference being is we're now looking at row number 2 in the array. So this shows how we can dimension an array as a user-defined type to contain hybrid data. You can put as many elements in the user-defined type as you actually require. So having got the data into that user-defined type array, how would we get it out? Well, as this is an array, we can use a for next loop as we've used in previous arrays. We can step through the array one row at a time. So if we wish to print out the student's forename and surname, we can push that out to the console by just using the print command. Since in the user-defined type we have defined the forename as being 100 characters, we don't want to print all 100 characters to the screen. The data in the field will contain a large number of blank characters. We can trim them out using the trim command. So this would effectively take the first row, forename, and trim off the trailing spaces. We're then putting a space after that, and we're also printing out to the same line the surname of the student. If we try running that code now, we would see we would get the names of both of the students printed on the screen. So we can get that information out quite easily. If we wish to print out the age, we can do exactly the same thing. If we wish to print the age element out to the screen, the age is held as a long type variable. And to print to the screen, we need to print strings. So we're going to use the format command to convert the number into a string that can be printed to the screen. This takes exactly the same format as before. We're going to take the user-defined type, the row number, and extract the age. And the format command, as it stands, will turn this number into a string that can be printed to the screen. So how do we handle the currency element? As this is also a number, we can also use the format command, which is one of the many string manipulation commands within PowerBasic. The format command has an optional parameter to say what format you wish the number to appear in. In this case, we're wanting it with 2 decimal places. So if we try running that code now, we'll see we get the name, the age, and the card balance of both of the students. So as you will see, the use of a user-defined type, especially within an array, gives a very flexible method for holding data. What we will cover in our next video is file handling, taking this kind of data and either reading it from a file or writing it to a file. But that's it for today. Thank you for watching.